Okay, this video will be on finite state machines. Now, in the previous videos, we talked about alphabets and strings and languages and how you can take, unions and intersections of them and combine them. Well, this video will sort of talk about the really, what goes on in computers. Now, a finite state machine is basically a machine. It's abstract, but what it does, it models how a computer goes from one state to the next. We have this right here means transition function. This means what happened, what exactly causes for the machine to go from one state to another. It makes a transition function on the current state. Now the previous state is the one it just left. It exited that one. Now and then the entry state is the one it's about to enter. Transition functions are the functions which change it, and it changes depending on what exactly what alphabet and what language you're working with and how you define your transition functions. Now here I wrote a directed graph label. If you guys ever studied graph theory, if not, I'm gonna just give you a quick load on what this all means. All this simply means is that SI, which I abbreviated for state initial, whoops, dropped the chalk there. All right, state initial mapped with the arrow to state one, and you basically just write down all the states, and you basically just draw an arrow to what they're connected to. It's really that simple. That just is a directed graph as modeled like, I think, to the best of my knowledge. I'm pretty sure it's what it is. So I mean, of course, I may be out of date. Graph theory is still constantly changing and developing, but that's for the purpose of this video. This will do. This is not a video on graph theory. It's a video series on computer science, theory of computation. All right, so from that, I said before, we have a finite number of states. The finite state machine is a finite state machine, not an infinite state machine. So it has to be finite, and it's we're not going to get into set theory again. We're just not going to get to that. Anyway, so let's talk about the more of a mathematical model behind it, not the super formal definitions. That may be beyond the scope of the video series, but we're just going to get into the general idea. So again, S is a total possible number of states, and then SO or sorry SI is the initial state. That's what I abbreviate for initial state. And it's also transition functions, which is delta, and then F is the final state. Now this is it's important to know there is something called a deterministic finite state machine, and then a non-deterministic. A deterministic simply means it's like you have an input, and then a transition function, then it outputs yes or no. Binary, yes or no. Deterministic. Like flipping a coin, and you call heads. Is it heads, yes or no? Is it heads, yes, and then tails, no. Now a non-deterministic finite state machine is simply that it's one that there's no correct, no given order. Like let's say you have a grocery list, or you're trying to find something that can be let's say you want to organize a collection of something in many different orders. That's non-deterministic. It's up to you to decide how you want to do it, and the number of possible states that has is the 2 to that that whatever number of possible. Let's say you have 5 I don't know lamps you want to organize, and so 2 to the 5th would be how would be the number of possible states for a non-deterministic finite state machine to do. If it could possibly organize the lamps. But anyway, so general idea is finite state machines are how computers really operate. You have an initial state, and then and then you have a transition function. You enter another state, and then you exit the state via another transition function, maybe the same one. They change depending on how you define your transition functions. And then and remember that the way it can be mathematically described is possible states, initial state, transition functions, and final states for the deterministic one. And then non-deterministic would be like 2 to the n, however many things for ND, FSM, for a non-deterministic finite state machine. Anyways, that's what it's really all about. Just one state moving to the next one via transition function. It's kind of the general idea behind it. All right, so that's I guess it for this video. Next video we'll talk more about other interesting things. But I said before, it's going to get I would say a little more exciting. And then now people will really for viewers viewing this, you'll have a more you'll better understanding of the mathematics behind computer science if this is completely new to you. All right, that's all for now. Hope you guys enjoyed. See you later.